Hi everyone, this is day 2 of our 6.4 word problems. So this is a new type of word problem. It's called an investment problem. Let's read it together. A student invested $5,000 in two different savings accounts. The first account pays an annual interest rate of 3%. The second account pays an annual interest rate of 4%. At the end of the year, she earned $185 in interest. How much money did she invest in each account? So looking at that question, we can tell what our let statements are going to be. So we have X as the amount invested in the first account. And Y will be the amount invested in the second account. Oops. Okay, sorry about that. Okay, so we have two different accounts that we invested $5,000 in. That is going to be our first equation. The amount we invested in one plus the amount we invested in the other is going to total the $5,000 that we invested. Our second equation has to do with the amount of interest that we pay. So the first one has an annual interest rate of 3%. The second one has an annual interest rate of 4%. So I'm going to attach those percents just like I did in the chemistry problem with the X and the Y. But in this case, I have to actually put 0.03 for 3%, change it to a decimal, and 0.04 for 4%. And the reason that we have to change these to a decimal is because in the total of this equation, 185, is already given to us multiplied. So in the chemistry problems, if you remember, we have a percentage here with the X, a percentage with the Y, and then we also have a percentage with our total. In this case, there's no percentage with our total. Since it's already multiplied in, we have to remember to change these percentages to decimals or we're going to get the wrong answer. So now we have 0.03, so 3% of the amount we invested in the first account plus 4% of the amount invested in the second account equals the amount that we make for interest, which is $185. And then to solve it, we do elimination just like we would. Remember to change out of decimals. So we're going to move the decimal twice on each number. You have to do it to every single number. So if I hadn't put the decimal, you see I would have gotten it very wrong because this ends up being 18,500. Okay, now I'm going to multiply this X plus Y times -3 so I can get rid of the X's. Our X's cancel. I get Y equals 3,500. So that is the amount I invested in the second account. And then if I plug it back in, X plus instead of Y, I'm going to put 3,500 equals 5,000. So subtract the 3,500. And I end up with 1,500 in the first account. So 1,500 was invested in the first account and 3,500 was invested in the second account. Okay, let's look at this one, which is a wind current problem. And if you notice, it says, I'm going to jump right to the question so I can look at my let statements before I start. Find the speed of the plane in still air and the speed of the wind. So let X equal speed of plane in still air. I have to write all that because I'm not looking for the speed of the plane. I'm looking for a hypothetical speed of the plane because it doesn't exist to have still air. There's always going to be wind. So I'm looking for the speed of the plane in still air, which is, imagine if there was no wind, what would the actual speed of the plane be? And my Y is going to be the speed of the wind. So these problems they follow the format of rate times time equals, oh my goodness, Let me rewrite it. Rate times time equals distance. Okay, and we're given a distance. It says a plane travels 8,400 kilometers. There's our distance. We're also given a time against the wind in 7 hours and with the wind in 6 hours. What we're looking for is our rate, because rate is speed, which is what our x and our y is. So our rate is going to be x plus y. So this is the speed of the plane in still air plus the speed of the wind. So we're adding in the speed of the wind. And then we have x minus y, which is the speed of the plane, taking away the speed of the wind. So one of them takes into account the wind because the wind is helping it. So you're going with the wind. The other one takes the wind away, so it pushes down on your speed because you're going against the wind. And when you go against the wind, you go slower, which is why we're subtracting it. When you go with the wind, it helps you, so you go faster, which is why we add it. So if we look at our formula again, we have rate, here's our rate, times time. So I'm going to multiply that by the time. So when I am with the wind, which is my plus, I'm going 6 hours. And when I'm against the wind, which is my minus, I'm going 7 hours. So I'm going to attach that time to my with the wind and my against the wind. And then they're going to equal distance, which is 8,400 kilometers. So again, we have the rate times the time equals the distance. With the wind is a plus, against the wind is a minus. Okay, now to solve this, what I want you to do is instead of distributing, because it's going to give you a lot more work, let's divide. Because if you divide, then you're going to make the equation much simpler and already set up for elimination. See, notice how when I divided by 7 on both sides and I divide by 6 on both sides, now I have two equations that are already set up to be eliminated. So my y's are going to cancel. I have to add my x's together. So I'm going to have 2x, because x plus x is 2x. These two I'm going to add together, so 2,600. And x equals 1,300. So the speed of the plane in still air is 1,300, and I can plug that back into any one of the equations, but I'm going to plug it into this one because it's much smaller and simpler. So 1,300 plus y equals 1,400, which means the speed of the wind is 100 kilometers per hour. So speed of the plane in still air is 1,300 kilometers per hour, and the speed of the wind is 100 kilometers per hour. Okay, let's look at another wind current style problem. I want you to look at this problem and see if you can do it yourself. It's very similar to the one that we just did. Just remember that it says 2 miles per hour, 5 miles per hour, which means your time is that 1 hour. Okay, pause your video and go ahead and try that problem. Okay, so in this problem, I already labeled my let statements. It's a little bit different than the last problem because, yes, again, my rate is going to be x plus y, x minus y. It is per hour, so I know my time is going to be 1 hour, which I don't really even need to put it, but I want you to be able to see it. And then my distances are different here because it says you row upstream at a speed of 2 miles per hour and you travel the same distance downstream at a speed of 5 miles per hour. So you're doing more distance when you go downstream per hour, and you're doing less distance when you go upstream per hour. So when you go upstream, which means you're going against the stream, so it's the minus sign, you're only traveling 2 miles per hour. But when you go downstream with the current, then that's going to be the plus sign. You're covering more distance, which is your 5 miles. So I don't really need the 1 because if I divide by 1, it's going to stay the same. X plus y equals 5. X minus y equals 2. My y's cancel. I get 2x equals 7, which means that my speed of my boat in still water is 3.5 miles per hour. And the speed of the current, if you plug it back in, is 1.5 miles per hour. Okay, here's another chemistry problem. Let's practice this. Take a second, stop the video because you don't want to see the answer right away, and try to work out this problem yourself. Okay, take a look at your answer, see if you did it correctly. Alright, let's move on to the next problem. Here's some more practice with those problems that we did in 6.3. So go ahead and try doing this problem. Pause the video so you have time to do it before the answer pops up. Okay, go ahead and check your answer. See if you did it correctly. Alright, let's do one more problem, which is a coin problem. Take a second, read the problem, find your let statements, equations, and solve it. Okay, so go ahead and check your answer. Here are your let statements, your original equations. This one we change the decimals and then divide it by -5. Cancel out the n and you get 70 dimes. Plug it back in and you get 30 nickels. Make sure you write down any questions that you have or put a star next to any of the problems that you didn't understand so we can go over it tomorrow.